Well, let's begin with the whole idea of change. When we look at populations, we all agree there is a lot of change, isn't there? I mean, if you look at the world around you today, you're sitting at the airport, you see people walking along, you recognize people look very different, right? It's estimated there's about 10 million normal variations in the DNA of man. All right? Now, is that evolution? I don't think so. Let's look at Darwin's finches. This is one of them that we see a lot in the textbooks. Darwin's finches are considered an example of evolution before our very eyes. Darwin observed when he went to the Galapagos Islands that there was a variety of different finches, and they had changes to their beak structure. Some had thick, strong beaks, some had thin, narrow beaks. And he made a couple of different assumptions. Number one, that these different type of finches all came from an original pair. So we started with finches, and we ended up with these different type of finches. His other set of assumption was depending on the type of beak structure that they had. If they had the thick, strong beaks, they would have an advantage in certain environments versus the one with the thin, narrow beaks. For example, if we're in a drought situation in the environment, the seeds would be very, very thick-shelled. As a result, those with the thick, strong beaks would be able to crush those little seeds and be able to eat. So they would have the benefit there. Versus the one with the long, narrow ones, they would be able to catch insects maybe a little bit better. But here's the question I have. What did we start off with? Finches, right? What did we end up with? Finches. All we're really seeing here is some variation within a kind. You know, as a veterinarian, I see much more variation within the dog kind. Think of the hundreds of different breeds of dogs that are out there today. You know, you have anything from a Chihuahua, and some people really debate whether or not that's really a dog, to poodles, to schnauzers, to shelties, to golden retrievers, to Great Danes. Now, we don't call that evolution, do we? No, we simply have a dog kind, and we basically begin to select out certain traits as breeders do, right? That information was already there. Now, these are small changes in respect of the features that we're seeing. Our textbooks call that microevolution. Micro meaning small, evolution meaning change. But the question we really need to ask ourselves, is this truly evolution? All I'm seeing here is genetic diversity that God programmed into the DNA from the very beginning. Now contrast this change with another type that we see in our textbooks. This is called macroevolution. Macro meaning big, evolution meaning change. This is the idea that one kind of creature changes into something totally different. Fish changing into amphibians, amphibians into reptiles, reptiles into mammals, and then finally man emerges. Now you should see evidence of these missing links in that transition from one to the next, shouldn't you? And yet we don't see that. We should have millions of these transitional forms everywhere we look. But also we should see it in the living record too, shouldn't we? You know, think of it. We have millions of different species of animals that are running around today. Wouldn't you expect that some of them are transitioning from one kind into something totally different? Do we see that at all? No. All we really see is what looks like the finished end products, right? Everything looks fully formed, fully functional. So all of a sudden we see that there's a big problem with this whole idea of change as an argument for evolution. We do see that there's minor modification within populations of creatures, but it's limited. It can only go so far. What we see is that there's some invisible genetic boundary that God established that we're not able to cross over. And we see variation within a kind, within the dog kind, the horse kind, the frog kind, whatever kind you're looking at. So genetic diversity, yes. Evolution, no.